now that we've done a little bit of CSS coding and we had to work with color, you saw that color is a little bit weird in HTML. So how does color work when we're doing some web coding? Color values in HTML coding look like this. And we saw some examples just now. These 6-digit codes that are a combination of letters and numbers. And they correspond to colors. Why? Why is this what they look like? Well, color values are based on the primary colors for print, red, green, and blue. Now note, that's a little bit different than the primary colors for light, which are red, yellow, and blue. The color code you see is actually a set of 3 values. That 6-digit code is actually a set of 3 values. The first is for red, the second is for green, and the third is for blue. So that's how these digits break down in that 6-digit code. Each value is a number from 0 to 255, or 2 to the 8th power. Why that number? Well, it has to do with screen resolutions today. That's part of it. It's 256 colors, right? Obviously, because 0 counts for 1, so that's a +1 on the end there. And 2 to the 8th power. So anytime you're talking computers, remember that all breaks down, all of the meaning in computers breaks down to binary code on its most basic level. Binary is just zeros and ones. So a lot of times numbering systems, when it's getting into the under the hood coding, breaks down to sets of switches that are on or off. That's binary. So lots of times things are based on 2 to some power. That's the scale for each of those values, 0 to 256. Now that value, though, is stated as a hexadecimal value. What on earth is a hexadecimal value, you may ask? So most of our numbering systems rely on decimal values. Think of currency, right? When you have that decimal point and the values that come after it, we count based on 10, right? Decimal, a base 10 system. Everything is based on those units of 10. Just the way that we think is really grounded in our decimal view of the world in a certain way. That's become our system, and that's how we label things. And that really, think even about our numbering system. We have distinct symbols for 0 through 9. Once you hit 10, you start reusing the symbols, right? You go back to the 1 again, and now you add a 0 on the end, and then you keep going and going. And by repeating those same symbols, when you think about it, there's an infinite number of values, right? But they are all represented with just those same 10 symbols, 0 through 9. We just keep repeating them in different meaningful ways to continue counting the value. So that's what a base 10 system looks like. But think about that. If we only need a limited set of symbols that we just reuse when we get to their maximum, that's really what a base is, right? It's the limited number of symbols. We really could have numbering systems that are based on anything, right? We could have, base 12, base 15, base whatever we want. Why would hexadecimal, which is base 16, be particularly valuable in computers? Because 16 is another one of those magic numbers that's 2 to a power, in this case, 2 to the 3rd power. The fact that 16 is a really great number for computers because we can break it down to a power of 2, and we've got our on-off binary, makes a hexadecimal system actually very friendly for computing values by a computer. So hexadecimal system is a base 16 system, and just like I explained, that means that counting, you have to have 16 distinct symbols instead of 10 distinct symbols. So what was done was 0 through 9 are maintained as part of the system, part of the symbols that we use, and then those are followed by A through F, which fill in the rest of the values in order to allow you to keep counting. So a complete set in a hexadecimal base 16 system is 0 through F instead of 0 through 9. And that's why the color values are a set of numbers and letters. So just to sort of reinforce and show this, we have our 0 through 9. That's the first part of our hexadecimal counting. Then A, B, C, D, E, F, and it doesn't matter if they're uppercase or lowercase, that is meaningless when it comes to the value. And those sort of correspond to continuing to count, but we need a single symbol in order to be able to do that. And that gives us all of our distinct symbols in our hexadecimal-based system. So that's basically what those symbols are when we're talking about hexadecimal color values. We now can see that these are numbers. It's just another way of writing numbers, but it's in hexadecimal code. The first 2 digits tell you the red value, second 2 digits tell you the green value, third 2 digits tell you the blue value, and they're expressed as hexadecimal. So this is encoded, and the result is a set of proportions that equate to the precise color values that you see on the page. Just as a reminder, you don't have to come up with these on your own. You don't have to learn about hexadecimal values or proportionality in order to use them. There's lots of great online HTML color pickers that will give you your hexadecimal values, and I have some linked in the resources, the web resources for this module.